Y'all are in for a treat today because I actually wrote a script for today's episode. So this video is about video games, but video games are software. Therefore, their fate is intrinsically linked to the fate of computing itself. We'll discuss an issue relating to computers, and you'll soon see how this is relevant to video game preservation. Now, if you're here for video games, don't worry, we're going to get to that. If you're here for software, then I suppose you're also going to have a good time. The most overlooked part of any story is the language it is written in. For most people, this layer of the storytelling stack is entirely invisible. For much of human history, unless you were unusually cosmopolitan, all stories you consumed were in a single language. While language evolves over time, it does so in lengths exceeding the average lifetime. Just as language has an X dimension, that being the fact that there are over 7,000 known living languages, it also has a Y dimension. Let me recite a few lines from the Canterbury Tales, one of the oldest works in what we would call Middle English. One that april with the shower suta, the dracht of March hath parsed to the ruta, and batterage vein is which liquor, of which virtue engendered is the floor. In zephyregs with the sweaty breath, inspired hath and every holten hith, so pricketh him that touren heard courages, than longed folk to go on pilgrimages. So even though that monologue isn't even in Old English, it's Middle English, it's still almost completely imperceptible to someone speaking conventional, contemporary English. So how do we determine what words actually mean? Well, we use dictionaries for the most part. The only issue with dictionaries, though, is that they use words to define words. And as the language evolves, so do our descriptive terms. This is why load-bearing stories and religious texts, such as the Canterbury Tales, which is a story, not a religious text, have been so important in preserving the language. They provide a sense of grounded context, where we can infer the meaning of terms based on the message of the text. This principle is not much different than what happens in computing, and this affects program compatibility at multiple levels. At the highest level, an issue most affecting scripted languages, syntax itself is highly prone to change. Python 2 is a very different language than Python 3, with even the print command being altered in an incompatible way. The JavaScript standard is constantly evolving with new commands and behaviors, forcing web developers to test their websites on many different browser configurations to make sure something doesn't break. Even languages as stalwart and immortal as C have grown substantially over time. Conventional C will often break when you try to use an ANSI C compiler. But even if languages remain the same, hardware architecture is evolving at an equal, if not faster, speed. What we refer to as x86 compatibility does not mean just one thing, of course. In fact, x86 is often referred to two separate processor architectures, that being AMD 64, and systems that are derived from the 32-bit Pentium architecture, which is itself a development of the 16-bit 8086 architecture. Despite high backwards compatibility, innovation has meant that many of these chips are entirely distinct from each other on the inside, with their own unique features, advantages, and disadvantages. This issue explodes in complexity once you factor in the incredible diversity of RISC chips and all the different incompatible architectures that all call themselves ARM. Many forces driving forward computing are written as a solution to this problem, adding another layer to, in theory, resolve many of these issues. The biggest of these was the invention of the operating system. Unix, as well as the C language, were originally designed to be neutral targets for both hardware and software. That's why they exist. If your machine can run Unix, and your software works on Unix, then there's a very high likelihood that your solution will function on another system that also runs Unix, despite the fact that on the inside it may be very, very different. However, just as everything in existence seems to be boiling and melting around us, there must be active upkeep to ensure that software remains compatible with contemporary hardware. If you want to run software written for the CP/M operating system, you really don't have a better option to use than an emulator, even though it was historically designed to run on the Intel chipset. In some ways, this issue is simpler when you move over to talking about game consoles instead of conventional PCs. Despite the even more dramatic levels of hardware and software diversity, there is a lot less variety. Significantly fewer types of game consoles have been manufactured than types of computers. And progress has always been made in more infrequent leaps. than in the smooth and varied gradient of enhancement you see in the PC market. This is why you can neatly categorize game consoles by their generation. It's not uncommon to find development for past generations in a way that is foreign to the PC market. When it comes to game consoles, it's not uncommon to find development for past generations of hardware in a way that's foreign to the PC market. There are substantially more homebrew games being developed for the Sega Dreamcast than there are for Windows 98. For example, I can even go to a game store in my hometown and pick up a new Dreamcast title right now. While the thrill of having your game run on perceived real console hardware is a really big part of this, another component is the concrete nature of console development itself. If I want to write a PC game, I typically have to learn a game engine, and I'm locked into that platform with its licensing, workflow, and limitations. At any time, a game engine can spark controversy, like Unity, forcing a developer to either wade through its madness or lose years' worth of work. Furthermore, without active game engine maintenance, project bases can become difficult to migrate, and thus incompatible with or unoptimized for future versions of Windows, macOS, or Linux. This is not an issue with homebrew, typically, since the necessary context for any game to perform well was set years ago. Of course, there are still issues with homebrew development on older hardware. Firstly, and most obviously, older hardware is not being manufactured anymore. While it's possible to find an aftermarket NES or Famicom knockoff that will play your game without any complaints, this becomes an issue for later consoles, particularly CD-based units, as the necessary hardware to achieve the original intended experience just can't be purchased new. FPGAs, or field programmable gate arrays, as a technology have made incredible progress in solving this issue. This technology essentially allows you to program the silicon itself so that you can implement hardware in software. It's possible to flash modern hardware to function as if it were a game console from 20 years ago, with almost one-to-one compatibility. However, the issues inherent to software that I mentioned earlier still apply. The System Verilog standard, which is a common FPGA coding language, has been updated 3 times since it became an IEEE standard, the most recent update being in December 2023. And there's really no way to know how that's going to change over the next few decades. Since the mid-2000s, it has become very, very difficult to stay on top of the conventional gaming paradigm. Video game consoles are loss leaders by design, meaning that the console itself is sold at a loss, and the development cost is made back through game sales. Every game console is therefore very difficult to crack, and more difficult to emulate than the last. Often, each development is exponentially more complex too. While Switch emulators exist and are pretty good, the original Xbox is nearly 25 years old. Despite capacitor leaks often making the original console hardware useless, only 5% of original Xbox games can be played with perfect compatibility. I believe the reason why game preservation is on everyone's minds is that, historically, there's very little precedent for this sort of crisis. If a well-educated English speaker were to come across one of the original copies of the King James Bible in a museum, which were first published in 1611 by the way, they may be capable of engaging with its text. Meanwhile, macOS has not supported 32-bit applications since macOS Catalina, released in 2019, even though Xcode 9.2, released in 2017, is capable of producing them. It is reasonable to believe that a video game produced in 1985 for the NES may survive in 100 years, while a video game produced right now might not. In the far future, there may even be far more games from the 80s than from today. So what can be done about this? Well, several things can be done about it. If you're interested in writing a game that is easy to preserve, I highly recommend getting into homebrew development. It's a lot easier than you might think. GB Studio is a drag-and-drop solution that could allow anyone to make a real Game Boy ROM without any code. And if you're fine with code, then the Game Boy Advance is one of the easiest consoles to develop for. I've made 4 games myself, and I have other videos on my channel that can teach you how to make your own. Some other projects to check out are Simulant, an engine for Dreamcast and PC that is syntax that isn't really that different than Unity, as well as Raylib, a modern, easy-to-use, code-only engine for PC that I like a lot, that has candidates for many legacy consoles such as the PlayStation Portable. Homebrew ROMs tend to be extremely small and extremely compatible, so much so that my website features a GBA emulator entirely written in JavaScript. so that you can play my console titles without downloading anything at all. Another project I've been working on to make this issue easier to deal with is to artificially impose generations on PC titles. GameSystemRequirements.com only includes the minimum requirements for traditionally published games. However, I've written a parser script that pulls the statistics, normalizes them as much as possible, and then puts them into a MySQL database. I've learned a couple of interesting sets of statistics from this information. I'm using a sampling of about 1,710 games right now, and I've pulled their minimum operating system requirements. Out of this set, the most common systems were Windows 7 with 630 games, Windows XP with 620 games, and Windows 10 with 256 games. I then queried, based on these operating systems, to find a GPU mark score for all of the games that require those systems, and then I just found the maximum GPU from that list. I decided to include Windows 98 in this next set of statistics because it's the last PCOS to be based on the 9X kernel, and I figured it deserved to belong because there's a lot of PC games from that time period. For Windows 10, the GeForce RTX 2070 is going to run just about every game. For Windows 7, the GTX 970. For XP, the GTX 560. And for Windows 98, the 305M. Now remember, these aren't the recommended cards for all games. They're just the most powerful out of all minimum recommended for each operating system. If a game supports this operating system, then it will run with the corresponding GPU. These, in combination with a healthy amount of RAM and CPU speed, which I anticipate will be significantly higher than they are right now in future PCs, are a good set of standard specs for future emulators to target if we want to build systems that will run conventional PC games. We don't have any way to know how the future is going to go. I can say with great confidence that there is an incredible effort, much of it unpaid, in the field of video game preservation. Historically, some of the most fascinating programming has come from game programmers, and the determination behind many contemporary emulation projects is astounding. Hopefully, this video gives you a scale of what's at stake. As long as we find good standards moving forward, then our only concern will become DRM and online activation servers, which, well, we'll get there when we get there. Thank you all for watching, and don't forget to tell me what you think about this video in the comments. I will see all of y'all later. Peace.